everyone. In today's video we are going to see what is electromotive force. So in previous video we have discussed the complete working of the galvanic cell or electrochemical cell. So due to what in the last what we have discussed is because of the movement of electrons only the EMF is produced. So what is this EMF is the difference of the potential. So because of the charge difference only the electrons will move. That means for zinc it has a capacity to lose 2 electrons. For copper it has a capacity to absorb 2 electrons. So we have the difference in their charges. One is plus 2, other one is minus 2. So that is the reason only the electrons are flowing. That means both are not neutral. The electrons are charges are not balanced. That is why the movement is taking place from one electrode to the other electrode. Here we mention that high potential to low potential. That means if there is a high charge from that end only the other electrode will take. So how long this movement will happen is until both the charges are equal. That means both the charges are balanced. So in that process only, that process of the flow of electrons will produce the EMF. Generally this is calculated by this formula, E complete cell. That means electromotive force of cell is calculated as E right minus E left. That means right side whatever the charges are there on the right side minus whatever the charges are there on the left side. Whatever the resultant we get, that is the voltage or electromotive force. So because of this electromotive force only we will be able to produce the electricity. Okay, E right means reduction potential, E left means reduction potential of left hand side. Okay, we have seen those reactions, right? Zn plus 2 electrons gives Zn plus 2 and copper plus 2 electrons will give Cu. So one reaction will be left, one reaction will be right. So that is what here mentioning the E right and E left means. Now let's see some applications. So what are the applications means? Potentiometric titrations. So in chemistry we have titrations. So in this also what happens is the movement of electrons only. Because of those charges only we will get different substances as a result. So in this titrations we will use this technique only. Okay, electromotive force, and then transport number of ions can be determined, and pH also can be measured. pH is a value. Okay, hydrolysis constant can be determined. Hydrolysis also works on the principle of this electrodes and movement of electrons and all. So I'll just tell you with a basic example. So what happens is in one container you have taken hot water and in the other container you have taken cold water, and now you are connecting both these connectors using some pipe. Okay, now what happens, I mean you have dipped in completely. Okay, now what happens, this is hot and this is cold. Now some hot water will flow from here to here, or the cold water will flow from here to here, until how much time there will be movement from here to here is until both the temperature of the water in both the containers is same. Okay, this is called as equilibrium. Also the same equilibrium principle is applied in the complete process of this electrodes only. So until the charges are balanced, those electrons will be moving from one potential to the other potential. That is what I meant to say in all these videos. Okay, thank you.